target 10-3, what I'm looking for you to be able to do is simply sketch the pH scale, all right, which would be, you could just do it like this, 0, 7, 14. That's how you do that. And then tell me, okay, where's the acidic region? And the acidic region is here. Where's the alkaline region? And where's the neutrality region? Okay, this is neutral. All right, and then I could ask you a series of questions to test your understanding of this. One of the questions I could ask is, you know, why are smaller numbers more acidic? Because a pH 0 is way more acidic than a pH 5. So how do you make sense of that? And the answer is to remember that pHs are just really the logarithm of the H3O plus concentration, the negative logarithm of the H3O plus concentration. And if I were to put the H3O plus concentrations on here, okay, this would be 10 to the 0, this would be 10 to the 7, negative 7, this would be 10 to the negative 14, this would be 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4, 10 to the negative 5, 10 to the negative 6. Notice that as we're going this way, less acidic, we are getting less and less H3O plus amounts. All right, because a 10 to the negative 2 is a smaller number than a 10 to the negative 1. And therefore, these are the bigger numbers. The big H3O plus concentrations are down on this end. And therefore, when you take the negative log of them, the numbers look smaller on the pH scale, but they're really not. Yes, 0 is smaller than, say, here's a 1 and here's a 5. 0 is smaller than 1, that is true. But that's really 10 to the 0, and that 1 is really 10 to the negative 1. So if you remember that, that's actually the smaller number. And if these numbers are just the negative logs of the H3O plus concentration, those are the bigger H3O plus concentrations. So it makes sense that things would get more acidic that way because then the concentrations are getting higher of H3O plus. All right. Yeah, I could ask you questions like, okay, what does it mean for something to become more basic? You know, why is a pH 13, not 31, 13 more than a pH 8? That's asking you to remember this relationship. What we're seeing up here are the H3O plus values, but H3O plus times OH minus add up to 1.0 times 10 to the negative 14 in water. So when you change the H3O plus value, make it go up, I had said that this is a constant value at equilibrium, then that means that the OH minus has to drop to compensate, so that if they always multiply out to 10 to the negative 14. That's just something we see in water, that no matter what the H3O plus concentration is, it and the OH minus concentration, which exists simultaneously, must multiply out to be 10 to the negative 14 at room temperature and atmospheric pressure. So that's just a property, a fact of water. All right, so if you raise this, this is going to drop by a factor, same factor. So why is pH of 8 a base? Well, that's 10 to the negative 8 H3O plus, which would be 10 to the negative 6 OH minus. It is in this realm that the OH minus concentration is higher than the H3O plus concentration. And that's what a base is. A base is a solution where the OH minus concentration is dominant over the OH, or over the H3O plus concentration. All right, so hopefully that helps. Talk to you later.